Welcome to classes on physics, and it is the continuation of the last class 4, and some 4 or 7 or 8 numbers of the problems on solution of IIT, IEEE, PMT, CBSE, PMT, JEE, JEE, MN, etc. exams already left out, and that's why today in my class I will try to solve all this problem with explicit explanation. Can minutely follow the classes. The first class is a ions in a helium ion a helium ion in its first excitation state. Excitation state is in a helium ion is in first excitation state. Find its ionization energy. So first of all, we need to find out its energy. And before starting this one, let me just first explain two things, very simple two things. You may be very often confused. That sometimes we use a energy formula is like this, and sometimes we use the radius formula is like this, and sometimes we use in contract form, in short form. And which case, which formula will be applied? I am giving you the short form. The shortcut way to keep all this in your mind is very simple. You find it, you see the Rn. It is a normal formula of the radius Rn. And from this formula, Bohr has calculated Bohr orbit. When we talk about Bohr orbit, we just assume n is equal to 1 and z is equal to 1. That is for hydrogen, ground state hydrogen, n is equal to 1 and atomic number z is equal to 1. Am I right? When you put n is equal to 1 and z is equal to 1, all other things remain constant. We find the value is 13.6 electron volt EB. And when we calculate the energy in nth orbital is this, for the first orbit of hydrogen atom energy when we calculate. So again we assume n is equal to 1 and sorry, this is Bohr orbit. It is 53 Armstrong. And when we talk about energy, we are again assume z is equal to 1 and n is equal to 1. So that value is found to be minus 13.6 electron volt. Now the fact is that with the concept of this Rn and En, we will try to find out the radius of helium or radius of other monoatomic system. Say helium monopositive, it is single electron system. Lithium dipositive, it is single electron system. We will try to find out this, but the problem is that when we try to solve the problem or radius or energy of electron in monoelectron system like helium and lithium, so there is a question change in the atomic number, z, change in z. Here z is equal to 2 and here z is equal to 3. So we need to concise the formula. Either we can write this is 5.3 or we can write R1. Say Bohr's orbit. It is fixed. It is known to us. And then in its place, we do what? If it is helium or lithium, if it is asked, then we will keep n as it is and z as it is. So likewise, this value is the same for n is equal to 1 and z is equal to for hydrogen. If you want to find out the calculate the energy in lithium 2 and z helium 1, we need to do here is z is there, n is there. Am I right? So here 13.6 for calculating 1 and 2, z is equal to 1 and equal to, it is fixed. It is both hydrogen atom, energy of hydrogen, electron in hydrogen, and with this here in above z square is there and n square is there, because that z is related to other atom or ions, hence z will change, and n is again related to hydrogen also or other also, because it may be first excited state, second excited state, third excited state. Then with this we will change the value 1 2 3 and z according to the atomic number of this. That is why we will sometimes we'll apply this formula, sometimes we'll apply this formula. But here you see the hydrogen ion in its first excitation state, hydrogen helium ion is in its first excitation state. So what is its ionization energy? What is its energy, total energy? What is its energy? Energy of that electron is equal to minus 13.6 into, the formula is into z square by n square. Since it is helium, let me write the formula z square by n square. Am I right? Minor to follow. Here 13.6, z is here what? Means it is helium, atomic number is 2 square, and again it is fast excitation state. In my last class I told you, then since this is nucleus, this is 1 2 3, n is equal to 1, n is equal to 2, n is equal to 3. When you talk about fast excitation state, means electron has jumped from on absorptions of energy from this level to that level, that it has already gone to the n is equal to 2 level. Am I right? So when it is told fast excitation state, means electron is in 2, means n is equal to 2. So here for fast excitation state we'll put the value of n is equal to 2. So the energy is same. Am I right? Now it is ionization energy. Am I right? So ionization energy is equal to 0 minus that energy, total energy 13 minus 6, that is equal to, very simple. Just sometimes you think z square and sometimes zn, sometimes z is below and sometimes z is above, sometimes z is single z, sometimes z is square. In terms of energy, z is above. In terms of radius, z is below, z is single in radius. From the formula, z is single, and from the formula z square e in case of energy, z square by n square. So you minutely keep this thing in your mind. And that question was asked in ZW. Am I right? That question was asked in ZW. Question was asked in CBSE PMT. In Bohr's model of hydrogen atom, just I am going to in a coal mine, you just go to the questions. In Bohr's model of hydrogen atom, the centripetal force is furnished by the Coulombic attraction between proton and electron. If A0 is the radius in ground state, m is the mass of electron, is the charge of electron, epsilon naught is the vacuum permeability, and the speed is very simple. What is centripetal force? Centripetal force is equal to mv square by r. And what is Coulombic attraction? Coulombic attraction, it is Z, charge is E, proton and neutron is in the nucleus, and it is electron moving with velocity b and mass m. Am I right? Everybody of you know. So what is Coulombic attraction between electron and proton? So the charge is E. So K Z square K Q1 Q2 by R square. One Q is equal to E, other Q is equal to E. Q1 QE E by R square. This is Coulombic attraction. That should be balanced. This is equal. But the condition is that simple. If A0 is the radius in the ground state, then that radius mv square is equal to A0 and kz square by r0. So on cancelling out, we get mv square by A0, sorry, mv square is equal to kz square by r0. Therefore v is equal to one thing I have missed here, epsilon naught is equal to vacuum permittivity. Here we know that k is a constant, but when it is given permeability E naught epsilon naught, we know the value of k is equal to 1 by 4 pi epsilon naught. So we need to do here is, that is mv square a is equal to r is equal to r naught, k is equal to 1 by 4 pi epsilon naught, z square by r0, that is cancelled out. So v square 4 pi epsilon naught r0 is equal to z square. Therefore v is equal to z e root over 4 pi epsilon naught m. We will miss this z because it is hydrogen. Z is equal to, for hydrogen, z is equal to 1. So the relation is this, very simple. You simple go through this one, you can understand, very simple, nothing to explain. Simple calculation is there. CBSE PMT, the question appears in this: when hydrogen atom is raised to ground state to excitation state. I earlier in my first previous class I told you that when the atom is given energy and it's excited from ground state to excited states, that electron jumps from lower level to higher level. So when electron jumps from lower level to higher level, what is kinetic energy? Kinetic energy is equal to z square by twice r. Am I right? So when it's excited. So ground state to excited state means your radius is increasing. When radius increases, kinetic energy decreases. Kinetic energy decreases. When kinetic energy decreases, potential energy increases, because potential energy related to the h, more the length, more. So, so this is very simple, nothing to explain. I hope you can understand very easily without further. The question was asked in NEET 2020. The total energy of nth orbit of hydrogen atom. The formula of total energy is equal to minus 13. At the very beginning, I told you the formula is like this. Since it is hydrogen, so we will take zinc Z is equal to 1. So your answer is this. Nothing to explain. Again, it is very simple. Which is again asked in CBSC PMT. Energy of hydrogen atom is given this, ionization energy of nth orbital. The question is, energy of hydrogen atom is this much, energy of nth orbital of singly excited hydrogen helium, singly excited of helium is the target is helium. So what we need, say the energy of helium we don't know, we need to find out. So that energy, say En, that energy is equal to 13.6 . This is the energy of hydrogen, En, that may be 13.6 or anything. You know it already, it is given. If it is not given, En of any state, this energy is given. This is the formula of the hydrogen energy is equal to En by n square by z square. I told you earlier, En energy into z square by n square. If it is 13.6, you put here 13.6. This is the energy of hydrogen atom, and that hydrogen atom, with the help of this energy, we will find the energy of hydrogen helium. That's why we have written this one. So we say this is the energy of new helium. Am I right? So what is the atomic number of helium? Z is equal to 2, and since it is for hydrogen atom, that energy is equal to 1, and this energy is given as 13.6. It is equal to 4 into 13.6. You multiply. Very simple. Simple means for hydrogen, or that the n is equal to 1. For helium, n is equal to 1, and the energy of hydrogen is this much. So the z square by n square means z square by 1, z square equal n square equal to 13.6. En is equal to 13.6 given. It is the double of this. four times of this. Again was asked in NEET exam 2029, the total energy of electron in an atom is minus 3.4 electron volt. What is kinetic energy and potential energy? Very simple, you know it. Kinetic energy is equal to minus total energy, that is equal to minus 3.4 electron volt is equal to plus 3 electron volt. So kinetic energy is over. No need to calculate. Nothing is tough. What is potential energy? Potential energy is equal to twice of kinetic energy. So 2 of what is kinetic energy? Kinetic energy is this. Very simple. Just you apply the formula, you will get the result. Nothing tough, nothing to explain. The question was asked in NEET 2022. Please go to the question. T1 is equal to energy of the electron in the first excitation state in the hydrogen atom. T2 is the energy of the electron in the second excitation state of the hydrogen atom. Mind that before solving the question, let me first target excitation state. Excitation state. Whenever there is a question of excitation state, we need to go through the value of n is equal to 1, n is equal to 2, n is equal to 3, like this. We need to go, we need to know the value of our formula is equal to this. Energy is equal to En or E naught, that is E naught for hydrogen. It is fixed 13.6. whatever is this, we need not to write here because this will cancel out. It is fixed energy. Hydrogen atom for an, you can write it here. En is equal to z square by n square. Am I right? So what you are asked here is the energy of electron in the fast excited state means n is equal to 1, n is equal to 2, n is equal to 3. Fast excitation state is n is equal to 2. It is fast excitation state, and when it jumps further to the next energy level, it is called second excitation state, and that second excitation state means n is equal to 3. That things you should know because there is n. So n, first, second, third. First excitation state, it is second excitation state, n is equal to 3. So if T1 is the energy of the electron in the fast excitation state, this is the T1 of the energy of the electron in the fast excitation state, T1, then this E, you keep it fixed. E is 13.6, or you just keep it fixed. We won't touch it because it is fixed for hydrogen. It is for hydrogen. There is no change. So Z is equal to 1 and Z is cancelled, and here N is equal to what? N is equal to what means first excitation state means it is 2. 2 means 4. Have you not got 1? And very simple. This is equal to E naught. Now second excitation state means N is equal to 3 means 9. So T1 T2 is equal to 9 by 4. Very simple. Question may be asked in NEET and IIT and whatever the exam a question may ask. You please go through the question. It is very simple. But minutely follow. When there is a question of excitation state, you please then and then find out the value of n. If it is first excitation, value is n is equal to 2. It is second, if it is second excitation, value is 3. The question was asked in NEET 2018. The ratio of kinetic energy and total kinetic energy in modes of it. You may think that there is nothing is given. How can you find out? But you know the formula. Just you write the formula and you try to solve out. What you know? Kinetic energy is equal to minus total kinetic energy. Sorry, total energy. Kinetic energy by total energy is equal to minus 1 by 1. Or you can write kinetic energy by total energy is equal to 1 by minus 1. In the option, the answer was 1 by minus 1. That's why I am showing k is equal to this or t is equal to minus k. Whatever way you can write yourself. If you write it in this way, answer is minus 1 by 1. Again, 1 by minus 1. It is correct. Both the way it is correct. Whatever the option is given, you please choose the correct option. Just write the formula. The energy of electron in ground state of hydrogen atom is 13.6 electron volt. The atoms are excited to the higher energy level, and the emitted radiation gives 6 numbers of spectral lines, which transition gives maximum wavelength. Very tricky question and very interesting. You please go through the question and you will find interest in solving out the problem. Atom, hydrogen, excited. Hydrogen atoms are excited. Energy, forget about energy. Ground state energy, n is equal to 1 level is ground state. From 1 level, ground state means n is equal to 1 is equal to ground state. It was in the ground state. 13.6 means ground state energy. And it has excited. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. I don't know what was the higher level in which electron has reached. But the question is that electron again reverse back by releasing out the energy it absorbed. So when it comes back on emitting energy or radiations, it is seen that it has given 6 number of spectral lines. So this is the clue from where you can find out if it gives 6 number of spectral line, what is the position of the electron in the orbit, in which orbit it is. The spectral line is 6 means n into n minus 1 divided by 2 means this result is 6. I gave you the formula, spectral lines formula is this. So if you calculate it, I am not showing the calculation, you will find n is equal to 4. Because at the very beginning I show you when electron is the n level and when it comes back to the ground state, it gives 6 number of spectral line. In earlier question I have shown. But it is given the spectral number of spectral lines is equal to 6. Means the electron is in the 4th level. The electron is in the 4th level. So if electron is the 4th level, now what's happened? That electron may directly jump from this, or may directly jumps from this to this, or may directly jumps from this to this. A lots of probability is there. So you are asked which transition, which jumping will give you the maximum wavelength. Means lambda is equal to 1 by E. Less is the energy, higher is the wavelength. Am I right? So less energy will be 4 to 3 and 4 to 1 higher energy, least wavelength. So transition n is equal to 4 to n is equal to 3 will give maximum lambda wavelength, because less is the energy, more is the wavelength. More is the energy, less is the wavelength. This is the question, only one or two lines is the answer. Big and huge question. You will find it difficult to understand. Am I right? Very interesting, very excellent. Excellent question. Electron in hydrogen atom jumps from third excitation state, E4 excitation state, to second excitation state. 1, 2, 3, 4, 5, 6. I told you, whenever there is a question of excitation state, you jump directly to the value of n in which orbit it is. Am I right? So you see, if you are asked to find out lambda, lambda is related to what? 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Without this, you cannot find out here. In transition, you can't find out the value of lambda. So when there is n and n is there, but there is no question of n in the question, mention of n in the question. So from excitation state, if it is fast excitation state, from this level to this is fast excitation state. So we see, if it is fast, n is equal to 2. If it is second, n is equal to third. We have got the idea. So third excitation state to second excitation state means from third, its n value is equal to 4, and second excitation state means n value is equal to 3. So it is lower value. Lower value is the n1. So first condition, say it is lambda 1. First condition, we get r is equal to what? N is equal to 3, 1 by 9 minus 1 by n2 is equal to 4. You solve out yourself. This is 1. Now, what is second condition? Second excitation means third level, n is equal to third. First excitation state means n is equal to 2. So by second condition, what we get? 1 by lambda 2 is equal to r into what is the lower? 1 by 2 square is equal to 4 and 3 square is equal to 9. Solve out r by this. You take out the ratio yourself, simple mathematics, lambda 1 and lambda 2 will come out. The question is JEE mains. Very easily you can solve. Very interesting. The longest wavelength of Lemon and Balmer series, it is AIPMT. and double T. The question was asked. So you see, what is lemon? Lemon means n1 is equal to 1 and n2 is equal to 2, 3, 4, 4 dot 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 infinity. We don't know where from it has come. Am I right? But here you are concerned with the longest wavelength. Longest wavelength means if it is 1, if n1 is equal to 1 and if it is n2, if this comes from this, it is lemon. It is also lemon. It is also lemon. But which energy is the least energy? Least energy is equal to 2 to 1. Other energy is higher because energy is inversely proportional to lambda. We need to calculate the longest. Means the least energy is from 2 to 1. So for first condition, the lemon will be R is equal to 1 by this is 1. And it must come from 2, not from other, because if it is 3, 4, 5, energy gap is more the energy, less is the wavelength. We need longest wavelength, so we will assume here this. You find out this value. Am I right? This is 1. And now for second condition, Balmer, 1 by lambda b is equal to R. Again, for Balmer, n1 must be 2. Am I right? The electron must come to 2. So electron may come to 2 from this. So this energy from 3 to 2 is the least, but other energy is highest. Least energy means highest wavelength. So we will put here 3, not 4, 5, 6, because energy gap will be more. Wavelength will be small. We need longest wavelength. This. You solve out yourself and find out lambda L and lambda B. This is the ratio. The question is very simple and you can solve with the concept you have acquired in the chapter. It is a bit, I don't know, have you done, because sometimes the solid chemistry is omitted, sometimes solid physics is omitted in the syllabus. I can't tell you that have you done. Do you have idea on the solid chemistry? Have you done this? I don't know. A crystal, there is crystal lattice and this and that. If you have done, then you can understand very easily. Otherwise, from physics also, there is a question. From chemistry also, this question is very valuable. We know Bragg's law, B-R-A-G-G-S, Bragg's law. Bragg's law, in short, I am showing you. That is, this is interplanar distance of crystal. If there is a crystal, it has lots of plane, and this planes, one plane, another plane has a distance, interplanar distance. And when you fall light upon this one, there is diffraction. Am I right? So later on I will explain diffraction, interference, you will get it. I will come to this one. So the interplanar distance is assumed to be in this way. If light falls, then there is a question of interplanar distance. Interplanar distance is the distance between the two planes in the crystal is interplanar distance. And according to Bragg's law, I can't deduct it as very small, within a very small time. That is twice d sin theta is equal to n lambda. This is Bragg's law. Please keep it in your mind. It is in very higher class. I think I have forgotten to write it is from IIT or this somewhere else. I have taken the questions. And twice the sin theta is equal to n lambda. Equation is that interplanar distances in a crystal is this. That is, in a crystal, the interplanar distance is found to be this much. And the value of the maximum wavelength for diffraction. What will be the value of the light? Value of the wavelength of the light which when falls on the crystal will make the light to diffract. Am I right? Diffraction maximum. So it is very simple. What is the value of sin maximum? Sine maximum is 1. Everybody of you know maximum value of sine is 1. So if lambda is maximum, for maximum lambda, sine must be maximum. So twice d of sine, sine is equal to 1. So what we get here, the question seems to be a very hard one, but I think it is as easy to much easy. Simple in one step. You put the value of sine maximum, that is the value of the lambda maximum. Am I right? So this is the rest part solution of my 4th class, and hope you have understood the class with attention, utmost attention. And in my next class, I am going to start nuclei. And first of all, I will give you the idea on the chapters, and secondly, the solution for board and NCERT. Then I'll go to the entrance level question as like atom. Thanks a lot for watching the class.